using either visible or non-visible light.
Hey, what's up? I call this a son you can see. This is copyrighted information, copyrighted I believe 2023 of around June time, but it's copyrighted under the name of son you can see, even though you can't really see like it's supposed to say. Hold on. There you go. Son you can see the relationship between son and man. I'm gonna prove how the sun moves in relationship to human beings and all living entities. The first picture I bring up is a picture of the sun by taking a camera and videotaping the sun by putting a sheet of paper in between the sun and a camera and videotaping. You can basically reflect the light of the sun into the paper. By doing this, I go over to a computer and basically magnify it like 500 megapixels. Then you can actually see the corona and the sun surface move, but it's reflected light. But without further ado,
using either visible or non-visible light. Much of what lies beyond this layer remains shrouded in mystery. Help us observe exploding solar flares, vast coronal holes, swaying spicules, intriguing sunspots in completely new ways. The sun is abuzz with lively activity, and so much of it would be invisible to us were it not for these imaging techniques.
so here it is, my computer program. After recording it and putting out the USB of the camera and plug it into the phone, I put in the color director 5 that comes standard on the laptop MSI, but they have different filter programs. Then I find the program and then I basically blow up the program onto the screen board because this right here, well, excuse me, the storyboard, this right here basically allows me to play the video. So as you see, I have the sun right here, then I press play. You can see I just blew up there about 150%. But then I zoom in closer. Now I'm over here to the left and messing with the filters. The first one is the temperature. Second one is the tint. We can make it brighter, dark. I go down. Next one. These just different things like contrast, brightness, um saturation, things of that nature. When you play with it, you can change the color. But as you can see, it brightens out certain parts. So parts that are real bright, it makes it a little darker or change the color. But you can clearly see the lines of the sun that's reflected onto paper by using this filter method. And on the other side is just the sun because I couldn't capture the whole sun on just a sheet of paper because of how light deflects. It only could capture half onto the half or portion of the sun onto a paper. And from that I can make deduction. Now for me to get a copyright, I must submit this over to the copyright office, and every point that I plan to prove must be proven. So for them to have given me the copyright, it has already been proven what I'm talking about. So as you can see by looking at this portion right here, which is the sun's surface, this yellow portion is the heat from the sun. Basically, I guess the sun rays and all of the heat that's coming from it were created by all of the hydrogen, nitrogen, the elements of the sun create this heat signature. As regular people, we have energy that emits from our body that's beyond the physical body. That would be in the same, in a sense, relationship, though the effect of the sun is far greater energy. But if you pay attention to the surface, you can actually see it moves in and it moves out, as in expands and it shrinks. So one portion could be collapsing while the other portion is expanding out. You could think of it almost like a heartbeat, because a heartbeat, the heart muscle expands out as you breathe in air, and then when you release the air, then the heart decreases, and that's how you have breathing. So at the top portion here is the portion that's moving forward, and a portion here is the back of the sun. This line that comes right here is the edge of the paper. So if there was no line right here, this would have a circle curving all the way around, completing the sun. But like I said earlier, I couldn't capture or deflect light to show a full circle, but only a portion. And a portion that you're able to see, you can see that it basically is expanding as it moves forward and decrease from the back. You can see the surface of the sun, how it is moving at different intervals. So I decided to put on a different filter to give like a way closer look at it. Now, as you can see here, you can see that it's moving along the side of the corona, almost like wavelengths. And how it moves, it almost looked like a rippling effect. You can see around the edge, especially right here, how the crest moving in and is moving out and is doing alongside the full crest of the sun. And where this part is um, deflated inward, you can see it inflates outward at other portions close by it. And you can see it builds up in certain places and collapses in other places as it moves forward. Now the forward position is hard to see from this position, but I have other pictures that I show. Or video for that matter. You can see this is being sucked in a sense, and being pushed out, and you see the whole motion of it changes, but it's not moving as one whole piece in its totality. It moves in sections. So the direction we know of travel of the sun is traveling from east to west. And as it travels from east to west, it expands or stretches forward, stop, then shrinks and stops. Stretches and stop, and shrinks and stops. The reason why I bring this up, because that's a different momentum than actually rotating. And when you think about it in the laws of physics, rotating would be a different momentum than stretching and shrinking. It'll be two different momentum, which is a opposite of physics. The inertia that causes it to stretch and shrink is the only momentum it have. For it to move in a rotating fashion, it would have to be a different inertia. And a property of gas that we all know and have been proven is to expand and decrease or shrink. Now I want to point out here they show atoms. When you compare the pictures of the pictures that I show, you literally see what our
views of the
cells.
processes involved.
You can literally see the actual cells of what I show moving in the same fashion.
Views of the processes involved that may provide new clues for fighting antibiotic
Also, when you look at these cells, they are stretching as well to I guess duplicate itself.
resistance. The work focused on the double-layered membranes of E. coli. Some of the most dangerous bacteria that infect humans have the same double membrane structure, which makes it hard to get drugs into the bacteria and kill them. The researchers used live cell fluorescent imaging to get a full view of the bacteria. This allowed them to see in real time how the different cell surface layers changed relative to each other during cell division. They then used cryo-electron tomography to get the first ultra-detailed, three-dimensional views of what happens within the double membrane structure during division. No other tool could reveal such detail inside cells. Here, a small opening between the membranes of the two daughter cells is captured moments before the cells separate. The team gained new insights into what controls the push and pull between surface creation that makes a bacterial cell grow longer and surface creation at the division site that allows new cells to form.
Now, they talk about a push and pull, but really is stretching and shrinking or expanding and decreasing.
And pull between surface creation that makes a bacterial cell grow longer and surface creation at the division site that allows new cells to form. Studying mutants that alter E. coli's DNA revealed that this bacterium contains genetic instructions that shape the cell's division site. Surprisingly, the mutants divide in several different ways, forming distinct shapes seen throughout the bacterial kingdom. By revealing more about how bacteria divide, the study promises to drive fundamental research and help in combating the worldwide antibiotic resistance health crisis.
Eukaryotic cell structures from an electron micrograph. First off, you can differentiate between the smooth endoplasmic reticulum and the rough endoplasmic reticulum because although both of them are networks of tubules I'm showing you here in orange, the rough endoplasmic reticulum is associated with ribosomes, which I'm highlighting here in red. They're present on the electron micrograph as little black dots. In this image, we can once again identify the region of the rough endoplasmic reticulum by its association with ribosomes. But the larger organelle present here is the mitochondrion. We can see here the lines that we previously represented on our diagram, the internal compartments formed by the inner membrane of the mitochondrion. This next image serves to show us the relative sizes of the nucleus to the mitochondria labeled M and the rough endoplasmic reticulum RER. You can see how much bigger the nucleus is than the latter two. Here, to be clear, I'm distinguishing between the mitochondria, which I'm circling around in orange, labeled with an M, the rough endoplasmic reticulum RER.
Discuss the
Now, before I move forward, I just want to point to the fact that when you look at this nucleus and look at all cells, their property is basically derived from that of the sun, and it operates the same as the sun. It is basically gas, which causing everything to expand out to its fullest, sequence of whatever, because when you look at people stretching or getting bigger, it's really because of gas. The gas in your stomach allows your stomach to get bigger and bigger and bigger. And there's a possibility without any gas, a very great possibility, nothing would really grow. Gas is a reaction by all the chemicals mixing, and reacting to oxygen, which is oxidation. Therefore, based upon that hypothesis, nobody would know truly, but there has to be air where the sun is for that type of effect to take place. Because in a sense, the fire will stop burning. You have solar flares that reach out the sun, off the sun, I don't know how many feet, but that's a process of oxidation. And when you look at cells, what making the cells grow and react would be the same thing, that mixture of gas and oxidation.
Endoplasmic reticulum RER.
discuss the importance of hydrogen ions. A water molecule can occasionally break apart into two ions, a hydrogen ion, which is H+, and a hydroxide ion, which is OH-. In pure water, a very small percentage of water molecules are dissociated or broken apart. However, it's very important that we keep track of these because these molecules are very reactive. Hydrogen ions and hydroxide ions are very reactive, so they can have a big impact on biology, such as cells. The concentrations of hydrogen ions and hydroxide ions are equal in pure water, which is considered to be neutral. Let's take a look at how this actually works. We have here H2O, and it can break apart into H plus and then OH. So H plus and then OH minus, which is hydroxide. And you can see the symbol in the middle there. It looks like an equal sign, but it actually indicates that the reaction can go both forward and backward. So it's a reversible reaction. So a water molecule can break apart or dissociate, but the products of that dissociation, the hydrogen ion, the hydroxide ion, can actually come together and reform water.
So this scientist said that it could basically form or disassociate, meaning break apart. When you look at the sun and what it's doing, the increasing and decreasing or stretching or shrinking is that of which it's forming and actually breaking itself down. So basically it builds itself as it I guess decreases itself, for lack of better words.
Goes back and forth.
And when you look at the sun, it goes back and forth through other images, how it builds itself and then breaks itself down, where the bubbles form up and then decreases as they pop to make itself neutral.
So again, pure water is neutral. Water will break apart occasionally into hydrogen ions and hydroxide ions. Now, when we add in something called an acid, this is going to change the hydrogen ion concentration. An acid is a molecule that donates a hydrogen ion to a solution. So the acid produces what's called an acidic solution. So an example you might be familiar with is vinegar. So if we add some vinegar to water, we'll make the solution of vinegar and water more acidic. And you can see a picture here of what this would look like. So we have our acid shown with an A. It has a hydrogen ion covalently bonded to it. We have this breaking apart, a dissociation, and now we have the acid, which has a negative charge, and then the hydrogen ion, which has a positive charge. Now, the opposite of an acid is a base. A base is a molecule that accepts hydrogen ions. So a base produces a basic or alkaline solution. An example would be baking soda, which you can find in just about any kitchen. You add it to water, and you will make a basic solution. So let's take a look at how that works.
In my greatest opinion, I feel that through all of my study, that the base for the sun is sodium nitrate. When you look at the eclipse and you watch that moon and the sun actually line, you're actually looking at the beginning of time, because it's still coming in close proximity of that sun. Well, whenever the sun was created umpteenth years ago, whatever, basically the moon and sun collided, and it's still doing the same thing. So a piece of the sun, a piece of the moon melted with the sun and caused this great effect, as which he's explaining right now, but about other things.
Have our base, and if you have hydrogen ions, and there's always some hydrogen ions in water, they can combine. So it's actually accepting a hydrogen ion, and it's in effect reducing the hydrogen ion concentration of the solution. So you've probably heard the term pH. pH is a scale that expresses hydrogen ion concentration. It ranges from 0 to 14. Pure water at 25 degrees centigrade has a pH of 7. An acidic solution has a pH of less than 7. A basic or alkaline solution has a pH of greater than 7. So the pH scale expresses hydrogen ion concentration. Of 1 unit on the pH scale represents a 10-fold change in hydrogen.
Now, this is CIG stuff.
One of the great mysteries of the sun is the difference in...
So, but it's supposed to show the heat and I guess the pressure that builds up from the sun. This is more dramatic or entertainment stuff.
Temperature from its surface to its atmosphere, where it increases by 1 million degrees in a process that is not yet understood. Generation of the high-speed solar winds emanating from the star is another process under scrutiny.
Violet imager sees the hot corona, so to speak, the atmosphere of the sun, at extremely high resolution, much higher than what we had before. And one of the problems that we are after is to understand why the corona is so hot. It's like 1,000,000 degrees or so, while the surface of the sun is 5,000, something like this. And that's really puzzling, and we're after that since decades. And we think that it's possibly because of tiny, tiny, tiny eruptions that go on all the time, but that are small, too small to be seen by other instruments. And now that with Orbiter, we get so close to the sun, we can finally see them. And we did see a lot of them in the first images that we took. And the closer we get, the more we see.
I see something different.
So we are really excited about this because we may finally be on the solution to that decade-long problem.
These measurements that the spacecraft is taken now and also later will be important to improve our understanding of the sun. One of the things we want to understand better is how the sun affects the Earth. But for that, you have to really understand how the activity of the sun is caused, how it evolves, and when, for example, such a cloud of solar material leaves the sun, how it also propagates through space and goes towards the Earth. So for that, we want to do several of those close passages to the sun to observe it from close by. And we also want to change the orbit of the spacecraft so that it can see the solar poles, because we have never ever seen those before, and they are important to understand the magnetic field of the sun.
A magnetometer, energetic particle detector, and a solar wind analyzer suite. It also carries a radio and plasma wave suite, which measures electric and magnetic fields around the spacecraft.
So now the whole payload is
I don't know what it does.
working together. It's actually a lot of work to coordinate all that.
However, inside the boundary, the magnetic field is much stronger, and solar material is much slower, tied to the surface.
That we've always known corona spins with the sun, spins the same speed that the sun does. But out at the Earth, the solar wind is moving straight out from the sun, so it's no longer spinning. Where that transition happens is very important for understanding, because that spinning of the corona actually helps slow down the sun. All stars get slower in their spinning as they get older.
Much of what lies beyond this layer remains shrouded in mystery, but we can see the benefits of using light of all different spectrums in our study of the sun. They help us observe exploding solar flares, vast coronal holes, swaying spicules, intriguing sunspots, and shape-shifting cells, just to name a few, in completely new ways. The sun is abuzz with lively activity, and so much of it would be invisible to us were it not for these imaging techniques. Maybe one day we'll find ways to see deeper, using techniques we can barely dream of currently, just like those ancient generations of humans long ago could hardly dream of the methods we're utilizing these days. This constant rising and falling of solar energy levels thrums through our planetary system, rising and falling like a heartbeat. And surprisingly, even though we can't see it, we here on Earth move to its rhythm. It's hard to find anything on Earth that could live without our sun. But beyond the gift of that life-sustaining energy, it's easy to think of the sun as fairly static. We see it rise and fall in the sky, but we rarely notice it undergoing any sort of change. This, however, is an illusion. The sun changes all the time. As science has advanced and we've been able to shield out the worst of the sun's glare, it became possible to study the sun's surface.
Here's a website where these images come from, that's CIG. So I just happened to stumble upon this while doing research and other things, and the effects that I've showed you is not similar to this. And anybody could do what I'm talking about. You just need a video program that can blow it up to like, what, 200% or like 400 megapixels and keep it as a video. This is a program that I use to record my screen to bring these videos to you. So it's hard getting the videos and stuff to play. Maybe it's my computer. I'm gonna have to cut this short because my battery is running low on. Nice little test run since I've been putting video out and nothing really seen, so you get to see something until I do another live. But here's a portion of the video being loaded. Sorry that I'm not able to do the full video. Hopefully everything be fine next week. I've been having some technical difficulty. So I just go through the website looking through it, and here's these images. And as I zoom through, nothing really happened as expected. And it took so long for the videos to really upload. I really don't even waste my time trying to record anything. I'm gonna go ahead and skip to the next scene. This is the scene I'm gonna have to cut from, but as you see, I just zoomed into the moon. This to me is a treat because how the moon moves in relationship to the sun is far different. The moon is lighter in composition and the materials and elements that it have, making it a lot denser. Therefore, the moon in comparison to the sun pretty much floats, as this will show. I can't show the full extent of it like I did the sun because my video is running, the battery usage is low, so. And I changed the filter for it to have been seen. But as you see, as it moves and I'm able to catch all of the moon because it's not a very great light, you can see as it lucented, it vibrates. And its movement is of such, this is no camera trick, no camera angle, you can do the same thing. You can clearly see that it kind of floats almost, and it moves almost together. But when you zoom in more and more and more, you can still see the surface of the sun moving in small increments as it inflates and deflates. But it does it as a lesser value, to where it's just harder to see. With, the video equipment that I have, better video will be coming, of course. Zoom in even more, you don't see the effect that you see with the sun, and I didn't have to reflect the moonlight of the sun onto paper.
Using either visible or non-visible light. Much of what lies beyond this layer remains shrouded in mystery.
Technical difficulty. Looking at the moon, you don't see no real great effect, and this is pretty much how it goes. To the next video, you'll see something better, but I hope you enjoyed this video. I enjoyed producing it. Fast forward a little so you can see a little action. You'll be staring at this for a long time. The other videos that have the close-up is a lot better. This is about the cutoff, so I'm just putting something because I know I've been trying to show this video for a minute and ain't really showed much. So I hope you're able to enjoy this and some of the things in which I speak about. Y'all have a good night. Lovely early morning.